OSPF special area types. Configuring OSPF special area types. Special area types. You see, special areas. For example, Korea. Korea is one special area, right? Can anyone go easily? No. It's stub. It's a stub country, meaning no one can enter from outside. You know, likewise in OSPF also we have some Korea. Some are Korea, some are Saudi Arabia. We have something like that. But Saudi Arabia nowadays it has become like one Western country. Very soon it is becoming one Western country after joining with China. That's a bad thing. A religious country cannot become like that. But what to do? They will work. It was a very nice country earlier, Saudi Arabia. Now, configuring OSPF special area types. We got 4 different special area types. Number 1, stub. Number 2, totally stub. Number 3, not so stub area. Number 4, totally not so stub area. All right. So, what are they? We're going to see now one by one. Now, to make it easy for you, what I'm going to do is, I'm going to write it here, but more detail will come in the following slides. Let me write it here so that the following slides, when you go through, it will be easier for you. If I write here, is it okay, this color, or you want me to? Okay, let me write it here. Stub. Second one is totally stub. Next one is not so stub area. The last one is totally not so stub area. We have 4 types. Now the stub, will not allow type 4 and 5 LSAs. Okay. Type 4 and 5 LSAs are denied into the stub area. Such area are called as stub area. When type 4 and 5 are denied, when type 4 and type 5 are denied entering into an area, that area we call it a stub area. Totally stub. Type 3, 4 and 5 are denied. See, when you don't allow type 4 and 5, what is not going to come inside that area? EIGRP routes. But then how will you be able to ping the EIGRP routes? Yes. Yes. How? How? Because when 4 and 5 are denied, the ABR will inject a default route. So using the default route, all the routers will come to the ABR, and ABR will know how to go to EIGRP. Only that area is a stub area, no, not all the areas. So your ABR has got one of the connection with the stub area, another connection with the backbone area. Yeah. Okay. You see, this is backbone area, and this is stub area, and this is EIGRP, and this is another area. Let's say area 1, area 2, and here is an ABR. When you make this area as a stub area, that this router ID is type 4, and the networks of this cloud is type 5. 4 and 5 denied, which means the area 1 routers will not be knowing about the networks of other autonomous system, another autonomous system like EIGRP or something, isn't it? External, correct, external networks. But they will be able to ping even now. They will be able to ping. How is that possible? After denying type 4 and 5, this router will inject a default route to every router in this area. In this area, every router will get one default route. Using the default route, all the traffic will go to this end, this border router. This border router knows about all very clearly because type 4 and 5 still exist in area 0. Area 0 should never be configured as stub, because area 0 is the only way via which other area will know about all networks, isn't it? Area 0 is the mediator, area 0 is the intermediate, area 0 is the backbone. Right. So what is the advantage of this? Advantage of configuring stub area is you no need to maintain too many routes in the routing table. Only OSPF networks, only OSPF related, OSPF running routers network will be available. All the that's what I'm saying. You see, your routing table will be smaller because you are not learning other area routes. Sorry, other autonomous system routes. See, to reach other autonomous system, why should you know the entire world network? You need to simply go from this end to your next ISP. You need only a default route, isn't it? So by creating an area as a stub, the area is going to only have the networks of local area as well as other area. It will not have the external E1 or E2 type because 4 and 5 is denied. But still they will be able to ping the external using a default route. Next, totally stub. Totally stub. What does that mean, totally stub? You see, type 3 also denied. That is why it is total. See, what are all the LSAs comes from outside? 3, 4, and 5. Is there anything else coming? Type 1 and 2 belong to local, isn't it? Type 1 and 2 belong to local area. All other LSAs are coming from outside. If you deny all other LSAs, we call it as totally stub. Yeah. totally stub. When you configure an area as a totally stub, even other area routes will not come. What is the advantage again? Again, small routing tip. See, whether you go to other area or other autonomous system, whether you go to other area from here, if you want to go to other area also, you should go here. To EIGRP also, you should go here only. Then why I need to allow unnecessarily these routes here? Not necessary. I can simply have one default route only. If you have that thought in your mind, then the option is totally stub. Totally stub. All these routers will have only local network, that particular area's network. No other networks will be there. That is what totally stub. So your routing table is going to be very small. At the same time, you will be still able to ping other area as well as other autonomous system. Same, same result, but better result, you can say. Same reachability, but more fast. Do you agree? Okay. Now going to the next one. Not so stubby area. Not so stubby area will not allow, you see, stub area means what? This is stub area, isn't it? SA. Not so. You say stub, but not so. What does that mean actually? Huh? You see, this not so stub area will deny 4 and 5, like a stub area. Like stub area, it will deny 4 and 5. That's why that stub area is coming here. But not so. What does that mean? It means even though we deny 4 and 5, you will be still learning EIGRP roots. How? Instead of 5, it will be converted as 7, which is not denied by stub. It is not denied by stub. It is converted as 7. Because it is 7, it is now allowed inside. Even though it's a stub area, why it is stub area? 4 and 5 is denied. Even though it's a stub area, still you got the roots of EIGRP. That's why it is not so. ASBR. ASBR. When we do the lab, we will understand this better. So, that is not so stub area. Now, this first one and this third one, every vendor knows. This totally word, this two thing. This is Cisco's. This is Cisco's. Fine. Totally stub, not so stub, and stub. 3 things over. Now, totally not so stub area. Meaning, same rule. 4 and 5 denied. Okay. So, are you there? Okay. 4 and 5 denied. 5 is converted as 7 and sent. But additionally, 3 is also denied. Because here when totally come, what is denied here additionally? Same story here also. Yeah. So, you see this one, same story, 3, 4, 5 denied. 5 is converted to 7. That is totally not so stub area. Simply not so stub area is this first one, and 5 to 7 is allowed. That's all. You understood? Now, if you understand this, now you can easily go through these pages. Special area types. You see, when an area is configured as a stub area, does not accept external LSA. Does not accept external LSA. Correct. When an area is configured as totally stubby area, does not accept external as well as summary LSA, which is type 3. Right. Now, some condition. For the stub and totally stub, for the stub and totally stub, for the stub and totally stub area, what are the conditions? An area can be a stub or totally stub if there is a single ABR. So there should be only one ABR in that area. Or in case if you have more than one, suboptimal path of the other area or external autonomous systems are accepted. Meaning, if you have more than one ABR between two areas, or if you have more than one ASBR, only one should be active, the other should be standby. You understood? For example, I have two routers as a ABR. That is not at all possible. Why, you know? You should not have like that. We will go and give high cost here for the routes so that this one will be low cost, all will be going. So this is active and this one is standby. This is how it should be. If you want to configure this area as a stub, this is how it should be. Yeah. So there is a single ABR. If there is more than one ABR, suboptimal routing path to other area or external autonomous system are acceptable. Next, all routers in the area are configured as stub area. See, not just one border router. Every router should be configured as a stub area. So you can expect this in my configuration. I'll be going to all the routers and configuring stub. Next, if you want to configure stub or totally stub, please focus only for these two, these conditions, okay? We learned 4. These conditions are not for 4. This condition is only for the first 2. Now, there is no ASBR in the areas. There is no ASBR in the area. Only then you can configure that area as a stub area or totally stub. Next. The area that you are trying to configure as a stub should not be area 0. Next. We have not learned virtual link. We'll be learning that. Remind me in the next class. Before we do stub lab, I want to teach virtual link. So the area should not be a virtual link. Actually, we can convert an area to be a virtual link. If you have, that's what we will learn that one. If an area is used as a virtual link, or to make it simple, they have said virtual link should not go through the area. Okay. If there is a virtual link going through the area, then that area is not eligible to be a stub area or totally stub area. But we should keep these 3 things in mind. Virtual link should not be there. It should not be area 0. There should not be any ASBR. All the routers must be configured as a stub, not just one router. Right. Next. See stub area. External is not allowed inside. You see? Instead, what is coming inside? Oh, I'm showing here. Default route is coming. You see, the other area routes are coming as type 4, type 3. Type 3 is coming. But external type 4, which is coming from RAPE, 4 and 5 is denied. Instead of those stuff 4 and 5, you got what? Default. ABR. ABR. See from where it originates. Right, configuration we'll see later. Now, totally stub, it is not only denying the external, you see the picture? It's not only denying the external, it is also denying type 3 coming from other area, isn't it? And this is Cisco proprietary feature. See the last point? Cisco proprietary feature. Next. Not so stub area. I told you, okay, now those rules that you learned, these are only for stub and totally stub, not for not so stubby area. Okay, these rules are not for not so stub area and totally not so stub area. But again, this rule is still same for all four. Which rule? This rule. Area 0 cannot be configured as any stub. Now, not so stubby area. It breaks the stub area rule. Stub area will never allow 4 and 5. So other RIP routes cannot come in. So it breaks the stub rule means what? It allows the RIP route to come in. Now, ASBR is allowed in NSSA. 1 minute, I need to pick this call. So it may take some time. If it is taking long time, we'll meet tomorrow. So, see, NSSA breaks the stub area rules. Meaning, you still learn external routes. At the same time, 4 and 5 is denied. That is why it is not so. It is still a stub area because stub area will never allow 4 and 5. But how do you see those routes? Because it is converted as type 7. It's converted as type 7. So that is why you see router 1 is allowed, meaning router 1 is the one which is bringing RIP routes. Isn't it? Router 1 is an ASBR. It is allowed in this NSSA, but it is allowed as type 7, not as type 5. Now, when this type 7 goes to router 2, it goes as type 7 because router 2 is connected to NSSA. It is also connected to backbone, but when it goes to backbone, it goes as type 5. You understood? It comes in as type 7, but when it goes to another area, it will automatically get converted to type 5. See, that's what you see here. ABR R2 converts that 7 to 5. Yeah? Next. ABR sends default route into NSSA. So this ABR, no, it will also send a default route. in case if you have another ASBR. ASBR, you have one here, another here, assume. For local ASBR, it is bringing us type 7. But for the other ASBR, which will be coming as type 5, it is denied. Instead, what it is sending? Default route. Autonomous system border route. No, ABR is area border route. This is ABR. R2 is an ABR. R1 is an ASBR. Autonomous system border route. Right. So all these things we need to see in the lab. Now one more we have. That is totally stubby area. Sorry, not so stubby, totally stubby area. Very simple. As I said, that's what I'm saying. We already saw that. Anyway, you forgot. You see, it is going to deny 3, 4, and 5. For that, it will go give you default route. But for this ASBR routes, it will have type 7. So in all the routers here, you will have type 1, type 2, and 7. You got it? No 3, 4, and 5. But this is a Cisco proprietary. Right? Fine, sir. We'll stop.